the next case we're going to look at is what happens if you're looking for an angle. Now, what I'd like to do is concentrate on the algebra of isolating the angle in the cosine law. And then we're going to talk about the actual example that's coming up next. So let's say I was giving you a cosine law equation. So d squared is equal to e squared plus f squared minus 2ef cosine d. If I was asking you to find an angle d, let's say you were given enough information to find angle d, you'd have to isolate cosine d in this equation to get angle d all by itself. Now there's two ways of doing that. I'm going to show you the more advanced way, and I'm not even going to talk about the second way. And here's how it basically works. Because cosine d is trapped inside of this term, the whole term is negative, and we don't like to isolate variables when they have a negative value in front of that term. So what we're going to do is we're going to move that whole term over to this side. And at the same time, because we don't want the d squared anymore on that side, we're going to move the d squared over to this side. So here's what it's going to look like. You're going to have a positive 2ef cosine d, which came from this one moving over to that side, equals the e squared and f squared don't change. And we're going to subtract the d squared that was on that side. Now we have to divide to get rid of the 2ef and get the cosine d all by itself. So cosine d is going to stay there. The e squared plus f squared minus d squared isn't going to change. But we're now going to divide by the 2ef. And one thing I'm going to recommend you do, and textbooks don't show this, this is something you need to know for it to work on your calculators. If you want to type this all in one step, you absolutely have to have brackets around the entire top and the entire bottom, which I've discussed with you before. Anytime you have a bunch of stuff in the numerator, adding, subtracting, a bunch of stuff in the denominator, adding, subtracting, multiplying, dividing, whatever it may be, you really, really should put brackets around the entire top and around the entire bottom. And that way you can actually type all of that into your calculator in one step. Now we're not done. We're trying to get d by itself. So what do I do to destroy the cosine? To destroy cosine, you have to arc cosine both sides, okay? To isolate d. Now, I wanted to discuss that because what kind of number should you be expecting as your answer when you do this whole division here? Because you have to arc cosine, it should be a number between 0 and 1. With a caveat, which I'm going to discuss with the next example. Okay? So let's move over to the numerical example of this. Now, I've got your numerical example down here. First of all, why do I have to use the cosine law for this question? Well, there is no angle given, therefore there is no sine law key. Okay? There's no sine law key if there's no angle given. You need an angle and an opposite side given to use the sine law. All right? So you can't use the sine law for this one to start at all. It's not a right angle triangle, so I have to use the cosine law. But I'm going to be using the cosine law to find an angle. Now, let me discuss what the problem is here. It says which angle is the safest one to start with, knowing that we usually use the sine law to find the second angle. So what do I mean by that? Well, let's pretend for a second that we find angle Z as our first angle. Okay? Let's say angle Z is 39 degrees. I'm just making that number up. All right? Now I have a sine law key. So now I could use the sine law. But here's the problem. That 9.6, which is your key length, is shorter than both of the other two lengths that we'd be using in the sine law. And we discussed that the ambiguous case is what happens when you're looking for an angle and your key side is shorter than the other side that you're working with. Well, the key side is shorter than both of those sides. So no matter which angle I'd be finding next, I'd have an ambiguous case for both of those scenarios. And we're trying to avoid the ambiguous case. Now, one way we could completely avoid it is by using the cosine law again to find our other missing angle. Okay? But what's funny is in textbooks throughout my education, they always recommend using the sine law to find the second angle, which we're going to do that in a minute, because it's faster. Okay? So what I want to ask you, based on what I just discussed with you, what angle should we start with? We can't start with z, so it's either x or y. Which angle should we start with? If we start by finding angle y, the opposite side to angle y is the longest side of the triangle. That means both of the other two sides are shorter than that side. And when your key side is the longest side, you don't have to worry about the ambiguous case at all. So if you're given the choice, you should always try to find the biggest angle, which is always across from the largest side, in a cosine law scenario where you're looking for angles. Then you can freely use the sine law and not have to worry about the ambiguous case. Or you could just use the cosine law for the two angles. Now the third angle is going to be easy because we're just going to use the 180 rule, right? But like I said, in textbooks, most of the time they do recommend you using the sine law as the second step to this. So let's set it up. We're going to find angle y first. I actually want to do the entire solution of this one with you. Now, what I would like you to do right now is a little bit of a mental exercise. I'd like you to see if you can isolate cosine y in the cosine law equation mentally. Okay? Using what we did on the previous slide. Now I'm going to go back to the previous slide for a second. Okay? Let's look at what's going on here. So here was our equation. We took this term, brought it over to this side, took the d squared, brought it over to that side, and then divided by the 2EF. Now, I feel like you should be able to do that mentally just by knowing the three letters that we're working with and what we're trying to isolate. So try to think about this. What would be the original equation? The letter that we'd have on this side would be y squared, because we're trying to get cosine y, and the only way to get cosine y at the end of the equation is if we start with y squared, because those two letters always have to match, just one of them's capital and one of them's lowercase. Okay? So there'd be a y squared here. That means what two letters would we have here? Well, if it was a y squared, it would be the other two letters. So it would be x squared plus z squared. And I'm using my cursive z here, so let me draw it a little bit better. So don't get confused about that, okay? And then we always have the minus 2 with all the rest of the stuff, but that moved over to this side, okay? The y squared that was on this side would have moved over as a subtraction over here. All of that would be divided by what? Well, what two letters are in front of the cosine y? The two letters are x and z. There's also the 2 that would become a positive 2, so you end up with 2x and z dividing on this side. So I feel like most of you should be able to, maybe with a little bit of practice, be able to mentally rearrange the equation to get cosine y by itself. Now there are some patterns that some students use to memorize this. If you're isolating capital Y, you're always going to be subtracting by little y squared. The other two letters are going to be their squared adding together. Also, the x and the z here will always match the first two terms here, but they won't be squared. And you just have to remember that there's a 2 in the denominator as well. So there are patterns that you can use to help you write this equation out, but either way, if it'll just save you some time if you don't have to write out the original cosine law equation and then isolate. Okay, but if you have to do that, that's fine. It's not that much longer. So let's label our triangle so we know what our side lengths are. So if this is capital Y, across from capital Y is little y, across from capital X is little x, across from capital Z is little z. Okay, so now we can put all of our numbers in here. So we're going to have cosine y is equal to, so little x, which is 14.7 squared, plus little z, which is 9.6 squared, minus little y, which is 20.6 squared. Oh, try to get that division line to be a little straighter than that. All divided by 2 times, now I don't even have to look anymore because I know it's going to be 14.7, the first term value there, and the 9.6, which is the second term's value there. And let's type this into our calculators. Now I'd actually like you to see me typing this into the calculator. So I'm going to switch over to my calculator. I'm just going to clear out some values here. I hope this works. Okay, so you should be able to see my calculator now. So I'm going to type in bracket 14.7 squared, right there, plus 9.6 squared, minus 20.6 squared, close the bracket, divided by, open the bracket, 2 times 14.7 times 9.6. Close the bracket, press equals. We get a very interesting result here. And I have had students tell me, so let me switch back over to the smartboard here. Oh, I got a negative answer, sir. It must be wrong. Well, it's not wrong. We can arc cos a negative answer. So if I arc cos that on my calculator, so I'm just going to arc cos the answer. I didn't round it off technically, like my calculator rounded it off a bit, but I just kept that decimal right in my calculator, and I'm going to second cos that, and that gives me about 114 degrees. Now, it's 114.2, but the distance between 1 degree and 0.2 of a degree is very difficult to see. If you think of a protractor, those two lines are pretty darn close to each other. So I'm just going to round it off to 114. So the reason I'm talking about that, by the way, is because we're not technically done this question yet. We still have to find another angle. So you really shouldn't be rounding off until you're done everything. But because degrees are so tiny, the rounding isn't going to be that big of an issue. So we now know that our angle y is 114 degrees. Okay, well now I have a sine law key. So let's say we find angle x next. Okay, so I'm going to say, this will be step 2 here. We're going to do sine x over little x is equal to my key values, sine big Y over little y. And because my y side is bigger than my x side, I don't have to worry about the ambiguous case. So I'm going to isolate and sub in the numbers as I go. So little x is 14.7 times sine of big Y, which is 114, all divided by little y, which I've forgotten the value of, 20.6. So I'll just do that off to the side and arc sine it as well. So 14.7 times sine of 114 divided by 20.6. So that's giving me 0.6518 approximately. So I'm going to arc sine 0.6518. Okay. And that gives me 40.6 degrees, which I'm going to round off to 41 degrees approximately. And for my third step, because I'm solving the triangle, I got to find the third angle. I'm just going to use the 180 rule. So 180 minus 41 minus 114 is going to give me my other angle. And that's giving me approximately 25 degrees. And now I've solved the triangle with no worries about the ambiguous case. Okay, so that was angle Z, which I forgot to write. And that's going to be it for today's lesson.